I'm Stanley. I'm gonna talk about part 1 and part 2.
In this part 1, we use the D-type flip-flop. We construct the circuit to prove the theory based on this truth table. When D is 1, there is no output, but when the clock has its rising edge, there is an output. So when the clock is off, no matter the output, the input is 1 or 0, there is no changes in output. Then the output will change only when I press the clock, which is the rising edge. For part 2, we use the D-type flip-flop as same as the part 1, and we connect to the clock modular, and we set the clock modular to 500 kHz. And then we use the oscilloscope to measure the output. As you can see, the voltage of channel 1 and voltage of channel 2, they are the same. And the input is 500 kHz, but the output is 200 kHz. It means that the D-type flip-flop reduce the frequency by half. Thank you.
I'm Long, and then I would like to talk about part 3 and part 5 of Lab E2. Okay, so for part 3, the clock is set to 1 Hz, and then we use a HCT161 4-bit binary counter and a HCT00 NAND gate. From the schematic diagram, the switch 2 and switch 3 is always open as to fulfill the counter's counting purpose. So when the switch 1 is open, the counter start to count from 1 to 6. So 1, 2, 3, 4, 5, 6, and back to 1. So when the switch 1 is off, it will stop at a random number covering the range from 1 to 6. Okay, so for part 4 and part 5, I combine them together. So for the clock, I first set to 1 Hz, and then from the schematic diagram, we build a circuit. This is the NOR gate we use, NAND gate, and then the 4-bit counter. So when I open the counter to count from 1 to 6, it will show the die pattern for each. And then when I open, this is 1, 2, 3, 4, 5, and 6, and then it backs to 1. Okay, so for part 5, we first, because the electronic dice is run much faster, so we increase the hertz, and then when the switch 1 is on and off, it will produce a random number from range from 1 to 6 with its pattern shown. So when I on and then off, it show 5, another time show 1, and 1, let's get a different, 3, and that's all.